In this video, I'm going to cover the discount cash flow. In previous video, I talked about the future value and the present value. So the future value, FV, is the value in the future after earning interest. The present value is the value of today of a future cash flow. Okay. To calculate the present value, to introduce the idea of discount rate, which is another name for the interest rate. Okay, so the discount rate is interest rate that used to compute the present values of future cash flows. And also there is another idea called the discount factor. So assume the future value is $1. Okay, what's the present value of it? And that's the discount factor. Okay, in other words, discount factor is the present value of a $1 future payment. Let's look into the formulas. Last class, I gave you the formula FV, future value, equals the present value PV times 1 plus R to the T. So that's a formula for the compound interest. And similarly, we can put the present value PV in the left-hand side. So we get the formula PV equals FV divided by 1 plus R to the T. So here, the R here is called the discount rate. And the T is the number of periods. So the present value is a way to discount the future value, discount the future payment back to today's value. And the discounted cash flow is the method of calculating present value by discounting the future cash flows. Let's look into one example. Suppose you bought a new computer for $3,000. The payment terms are 2 years, same as cash. If you can earn 8% on your money, how much money would you set aside today in order to make the payment when due in 2 years? So we just apply the formula we see here. Okay, the future value equals, the present value equals future value divided by 1 plus R to the T. So the future value is $3,000 as you need to pay the $3,000 in the end of 2 years. The interest rate or the discount rate here is 8%. So it's 1 plus 8% is 1.08. For 2 years, for 2 time period, 2 is squared here. So the present value equals 3,000 divided by 1.08 squared. And that gives you $2,572. Okay, so in other words, if you put this amount of money into the bank and you are earning interest of 8%, you will get 3,000 in the end of 2 years. Okay. So think about you are using a credit card. If you make a payment, you make a purchase today for say $100. Okay, and you are not paying the bank immediately. You pay until like in the end of the due date. Okay, so when you make a purchase for every month, there is going to be a closing date, so that will close all the balance you own in the bank and summarize all the purchases. And then you will have a month, usually 30 days or 28 days, that you need to pay this amount before this due date. And if you pay in time, in full, you will have no interest owned. But if you cannot make the full payment, you can just make a partial payment, and there is usually a minimum requirement of payment. However, if you don't make purchase today, but you don't make the payment today, you make the payment say 30 days later, you are actually purchasing today, but you are paying in the future. So actually you are like, what is the present value that you are paying is less than the price that you purchased today. Okay. Okay. And here is the formula for discount factor. The DF is the present value of $1 future payment. So FV is 1 as assumed, divided 1 plus R to T. Okay. So let's look into another example here. Italian borrowed money for 2 years, but it did not announce an interest rate. It simply offered to sell each IOU for 1,992.34 euros. And what's the interest rate here? Okay, for each IOU, and it's like a government treasury bond. So by default, the face value of it is 1,000 euros. So in the end of 2 years, you are going to get 1,000 euros. Okay. So here in this example, the present value, you need to pay 992.34 euros to purchase this IOU. And in the end of 2 years, you are going to get back the face value, which is $1,000, 1,000 euros. Okay, that's the future value. And the discount factor is 1 over 1 plus r squared, because it's followed for 2 years, so it's squared here. And you solve for the r, the discount rate, or the interest rate. So the r gives 0.385%. So that's the implied interest rate here. Okay. Next example, suppose, so in this example, you are going to see there are multiple cash flows. Okay, and the cash flow are of different amount. Suppose you are able to put $1,200 in the bank today and another $1,400 in 1 year. And suppose you are earning 8% rate of interest. How much will you be able to spend on a computer in 2 years? So there are two cash flow. Okay, so the first is you have 1,200 today. Okay, in the end of 2 years, the 1,200 after compounding interest will go into about $1,399.68. Okay, the other one is you have 1,400 in 1 year. So in the end of 2 years, it's only compound once. So it's 14,000 times 1.08, and that's $1,512. Okay, so there are two cash flow, and adding them together, you get the total future value, and that's $2,911.68. Okay, so in total, you will have this amount of money that you can spend on the computer. So this is you are trying to solve for the future value. Similarly, in the next, we are going to talk about we can use the similar method to solve for the present value. Suppose we know you are going to get a future cash flow, say you are going to get C1, C2, etc. in the future, and the discount rate is R. Okay? The present value is for each future payment you are going to receive, you are going to discount it back to today. So for C1, you are going to receive in 1 year, so you discount it by 1, so it's divided by 1 plus R. For C2, you are going to receive this cash payment in 2 years, so you need to discount it with the with 2 time periods, so it's 1 plus R squared, etc. And then you're adding all the future cash flow together, you get the present value. Okay? Let's see an example here. Suppose your auto dealer gives you the choice to pay 15,500 cash today, or you can choose to make 3 payments. You can pay 8,000 today, 4,000 at the end of the following 2 years. Okay? Suppose the cost of money is 8%. Which payment choice will you prefer? So the cost of money is 8%. It's the discount rate for you here. Okay, so for this future cash flow, 8,000 today, so it's already the present value 8,000. For 4,000 at the end of the first year, so it's discounted once. So 4,000 divided by 1 plus the interest rate 8% to the ones, and that's equivalent to $3,703 as of the present value. And you made another $4,000 in the end of the second year, so you need to have it discounted twice. So it's 4,000 divided by 1 plus 8% squared. So this is equivalent to the present value of 3,429. Okay, and then you're adding all those 3 cash flows together, you get the total PV equals 15,133. And this is actually, let me see here, this, then the other choice, paying the 15,500 today. So in other words, if you choose to make 3 payments, you are actually paying a less present value than paying in full today. However, this is all depending on the assumption that discount rate is 8%. You may try by yourself, say what if the cost of money is 7% instead of 8%? Or what if the discount rate is 10% instead of 8%? That will change the present value of your future cash flow. Okay. Okay, so lastly, let's put this into a graph just to help you understand. So for the 3 payments we have, for time equals 0, we pay 8,000 immediately. For t equals 1, we pay $4,000. For t equals 2, we pay another $4,000. So for t equals 0, there is no discounting here, so it's already present value of 8,000. For the future payments, we need to discount it by the number of time period, okay, and then you adding them together. Sometimes I think it's very helpful just to draw this graph and to draw the timeline and see how to discount the future cash flows of today.